Okay, the next part is we're going to look at applications of the law of sines, which is basically the idea of area and then word problems. So on this first one, it says find the area of the triangle. And if you look at the equations up here in the blue box, right? We've got some equations right there. Notice it's basically 1/2 the two sides times sine of the angle between them. So therefore, as we're looking at this picture, we've got our two sides of 16 and 10, and the angle between them is 30. So we just apply the formula 1/2 times 16 times 10 times sine of 30. And this one ends up being a nice number of just 40. Technically, you could call it like units squared if you wanted, right? Okay, let's look at the next one. Next one's a little trickier, and I feel like whenever they just give you the numbers, always draw a picture to go along with it. So, this is alpha equals 20. We've got beta equals 23. And you can always find out then the other angle, right, by subtracting these two from 180. And you get that the missing angle is 137. Okay, the side across from alpha is 6. I'm trying to say units. All right, so the problem here is I only have one side. So I have this side, and then I want to use one of the angles that touches it. It doesn't necessarily matter if you use the 137 or the 23. Since we have the 23 to begin with, let's use the 23. But I've got to figure out this side C as well to plug things into my equation. So you kind of need one from each part. One of the angles and then the two sides that touch it. So here, before I get going with the area, I first have to use, my knowledge that sine of 20 over 6 equals sine of 137 over c, and I've got to solve for c. Think about cross multiplying, but I think you picked up that c equals 6 times sine of 137 divided by sine of 20. So you end up that c is equal to 11.96. Now we're going to go back and use our area formula. So this is 11.96. I now can do my area equals 1/2 of 11.96 times 6, the two sides, times sine of 23. At that stage, you're just typing it into your calculator. Make sure it's in degree mode, and we end up with 14.02 units squared. Okay. So be aware there's kind of two types of area ones. Ones where you can just plug it in, and then there's ones where maybe you have to solve for something before you plug it in. Okay, applications are where it gets a little bit harder. So this first one's not too bad. They give you a picture. It says to determine how far a boat is from the shore, two radar stations are 500 feet apart. And the angles to the boat are shown in the figure. Determine the distance from the boat to station A, and so this is X, and the distance from the boat to the shore. So they're really talking about what they call the altitude, so like this straight distance, which I'll call Y. So let's come back to Y, but let's first look for X. So if I use my knowledge, first of all, that 500 is across from a side we don't know, so can we find the angle by doing 180 minus 60 minus 70, and we end up this angle at the top is 50 degrees. So we've got sine of 50 over 500 equals sine of 60 over x, and I used the 60 since it's across from x. So do your cross multiplying, x equals 500 sine of 60 all over sine of 50. When you type that in your calculator, and yes, you will want a decimal approximation, we end up with x equals 565.26. Okay, so that's the distance from the boat to station A, 565.26. Okay, I'm going to actually redraw a triangle over here to help you kind of see what they're asking for when they ask for the altitude, or in this case, they said like the distance of the boat to the shore, and the straight distance, maybe what they should have said. So 565.26, this is 70, And the straight distance will always be like a right angle. So we're looking in this case for what I called y, but also known as the altitude of the triangle. So here we're going to use some of our other trig knowledge. Notice I've got the opposite side and I've got the hypotenuse. So I'm going to say sine of 70 equals y over 565.26. Think about solving both sides for y by multiplying by the 565.26. So y equals 565.26 times sine of 70, which then gives you, sorry, I'll write that down, that y equals 531.17. In this case, they were talking about feet, so that label will be the same throughout. Okay, let's look at the next one. The next one, a man and a woman are standing 3.6 miles apart. So we've got this man and we got this woman, and the distance between them is 3.6 miles. Okay, there's a hot air balloon between them at the same time. They both look up at the hot air balloon between them at the same time. The angle of elevation from the man to the hot air balloon is 25 degrees. And then from the woman to the hot air balloon is 40. And they want to find the altitude, so how high the balloon is. So remember, this is like kind of like what we did in the last one. We're going to have to find one of the sides and then use our regular trig functions. And they want it in feet. It's up to you. If you want to convert that to feet right now, you can. I'm going to leave it in terms of a mile because I think miles are just smaller and easier to deal with, and then we'll convert it to feet at the end. So let's choose one of the sides. Let's say I call this side x. Well, in order to solve for x, I need to know what the angle at the top is equivalent to. So if I do my 180 minus 40 minus 24, I end up with 116 degrees. So we're going to have sine of 116 degrees all over 3.6 equals sine of 40 all over x. Do your cross multiplying, you get x equals 3.6 sine of 40 over sine of 116. When you type that in on your calculator, we end up with x is equal to 2.57. So now, if I look at that triangle, on the left, I got this is 25. For the record, don't try to fool yourself that like that's going to be half of 116. That's not true. And then this is 2.57. In this case, miles. We're trying to find the height. Let's call it something different. I'm going to call it y. So I'm going to do sine of 25 equals y over 2.57. So multiply both sides by that 2.57, and y equals 2.57 sine of 25. And then you get that that's equal to 1.086 miles. But remember, there's 5,280 feet in a mile, so I times that by 5,280 feet over 1 mile. Hopefully this seems a little familiar. Those cancel, and we end up with 5,734.76 feet. And it says nearest foot, sorry, so I should have rounded to 5,735 feet. Okay, last but not least, and this, while these ones are tricky, kind of understanding your directions, I think they will be important because as we continue on, we will do more and more with kind of our north, south, east, and west. So, first of all, a little reminder for you, never eat soggy waffles. We're going to want that in mind. So, Carl spies a potential Sasquatch nest bearing N, and then this should have been, just 21 degrees, not 121. So that says, that's basically saying 21 degrees east of north. Actually, I take that back, sorry, it should have been 12. And he radios his friend Jeff, who's bearing at 48 degrees east, so look at north, and then 48 degrees east of that from Carl's position. From Jeff's position, okay, well, let's just start with what that looks like. So what we're saying is if we've got Carl here and we go due north, so we draw a straight line there. If I just go over 12 degrees, that's where the Sasquatch is. Okay, however, if I stay in Carl's position and I go over 48 degrees, so this is 48, then I will get to where Jeff is. I don't necessarily know how long those lengths are. Okay, then it's saying from Jeff's position, the nest is bearing of south 70, so south, you got to draw a straight line down. Maybe I'll draw a different color. A straight line down, and then 70 degrees west, so kind of to the left, and this is 70. Okay, I feel like in these cases, like it's just a little hard to see kind of the triangle they're talking about. They are going to be talking about, you can kind of see the triangle that formed this triangle right here. So let's draw that a little bit bigger. Let's see if we can figure out what these angles are. So the angle at the bottom, you'll notice, we look back what we did in purple, is we had the whole angle was 48 degrees, and then the small angle over here on the left is 12. So what is going to be this leftover angle here on the right? If I take 48 minus 12, we'll get this bottom angle is 36 degrees. Okay, if I now consider the top angle, you got to use a little bit more of your imagination in the sense of if this angle here at the bottom is 48, then you can think about if I kind of enlarge this part. So this thing was 70, but notice how there's this line that intersects it in purple. And so since we kind of have like parallel lines here, if this angle is 48, it means that this one also is 48. So that angle that we're looking for in the triangle here, right there, is going to be 70 minus 48. So it's going to be 22 degrees. To find the last angle in the triangle, if I do my 180 minus 36 minus 22, I end up with 122 degrees. Okay. They also, maybe I'll put some other labels here. This is Carl, right? This is our Sasquatch, and this is Jeff. They also tell us that Carl and Jeff are 470 feet apart, and they want us to know how far Jeff is from the Sasquatch now, so that X. Now you've got it all set up, we're just using our law of sines. So sine of 122 over 470 equals sine of 36 all over X. So do some cross multiplying. X equals 470 sine of 36 all over sine of 122. You go ahead and you take a moment to type that in your calculator, and what you get out is X is equal to 325.759, but they ask you to round to the nearest tenth, so that's one decimal, so 325.